everybody. Oh gosh, that's loud. Sorry, that's my voice. It is naturally loud and they probably weren't expecting it. Thanks for coming to my talk. I know there was a lot of really good ones. Hopefully I live up to your expectations. I am a little nervous. It's been a while since I've done a talk and I was a little intimidated by some of the other speakers, so I do know, though, I'm in a room full of good developers. You've all self-identified as a good developer, so I'm hoping that means that you're a little bit open to listening to me talk about HTML today. Maybe it's like a refresher, maybe it's something new, or maybe it's just some validation for how you're already doing things. Any one of those would be great. But I do want to be upfront and tell you that HTML is simple. It's a friendly and forgiving language, and I think that's what makes it such a good part of the web development process. But because it's simple, we often make the mistake of assuming that it's not valuable. And I'm hoping that I can dispel that way of thinking today. Hopefully none of you think that, but if you do, I'm hoping by the end of it that you won't. There are about 140 HTML elements if you include the obsolete and deprecated ones. If you don't include those, it's 115. And of those, you're probably not going to use most of them. You probably won't need the math element. If you don't build tables regularly, you don't need the 10 that go with tables. If you don't do stuff with web components, you don't need slot and template. So for most of you, it's going to be well under 100 that you would need to use. Now, I did a very small survey of front-end developers in Perth, and these were the most common elements that they use on a day-to-day basis. Now, a H3 is supposed to be in there, but it messed with my columns, so I didn't include it. But if you add that to this, it's still under 20. 20 HTML elements. That means that there is a limited number of elements that you need to remember for your day-to-day work. Now, of course, there are other HTML attributes as well, but if you can remember the elements, you can just use MDN as a resource to figure out what attributes are valid for those elements. So it doesn't have to be a big burden or task to use HTML to its full potential. Now, in this talk, I'm not going to go through every element because that would take way too long. I've only got 45 minutes and we're running behind. So what I'm going to do instead is primarily talk about how HTML can improve your accessibility and your performance, as well as look at how you can make the most of the features that it provides. But to do that, I'm going to mention some, like a performance metric, as well as look at some accessibility devices. To set the stage for that, though, I briefly want to talk about how the browser loads our HTML. So we start with our HTML file, and the browser doesn't just take it as is, it converts it into a big, long string of text. And then it has to parse that text. And then it goes through it and it constructs our HTML, creating the parent and child relationships, creating something like you would see here, which is what you're used to seeing when you inspect your code in Chrome or Firefox or whatever. This is known as the DOM tree, or the document object model, which is what we use to manipulate, edit, and move things around on the page. Now, there are a few other things, but they're not very important for today, so we'll just focus on the DOM tree, which is constructed off what we provide. If you request a div, that's what it's going to create, right? It doesn't care what the HTML is, it's just going to do what we've asked for, like literally every other coding language that we use, right? So at this point, I want to talk about TypeScript, which I know is weird because this talk is about HTML, but I have a point, so we'll get there. Who is familiar with TypeScript or a typed language of any kind? Great. I asked this question a few years ago, and there was a lot less hands, so this is awesome. So TypeScript, for those that don't know, is a typed JavaScript language, does everything JavaScript can do, but some extra things. And you can, basically in your code, you can assign a type to your data, and then at compile time, it will throw an error if the value and the type don't match. Might look something like this. You have an interface and some data, and then you assign a type to it, string, number, boolean. You pick something that makes sense to the relevant piece of information. And if we're using TypeScript correctly, we're being very explicit about what the shape of our data should be. This makes debugging, writing, reading, and working with our code a lot easier. I would assume most people would agree. If you don't, that's a separate conversation. This is essentially what we do when we write HTML. We specify what type of content it is, whether it's a heading, a paragraph, an image, bold, italic, dates. There's a whole suite of elements that you can use in order to best represent your content, to give it the correct type. And we do this for similar reasons that we use TypeScript, to make it easier to write, read, and work with. And in TypeScript, we have the concept of an any type, which means the data can be anything. But if everything is anything, then you lose the benefits of the language. And the same applies to if you use divs for everything. You lose the benefits of the language, right? This is why it's important that you actively choose the right element to represent your data, and don't just default to div, because if you choose a generic element, you're going to get generic output. And that's not what good developers do. We're specific about what we want. For example, this page I made many years ago, that's my dog Jello, is all made up of divs. And it's okay. It's just a blob in comparison to a page that uses the correct elements for each type of content. You can immediately understand it better. There's a lot more information just by picking the right type for your content. There's a structure, there's a hierarchy, and it's a lot more readable. And yeah, you could replicate this with CSS and JavaScript, but particularly in the case of CSS, that's just cosmetic. It's not functional. In fact, in a lot of cases, you're faking that functionality and the context as well. And additionally, it's way more work for you to do that, so I don't know why you would. And it's hugely problematic for technology like assistive technology and other things like Google search bots, that kind of thing, that rely on you writing your HTML correctly in order for it to be interpreted. Because not everyone and everything is going to interact with your website the same way. There are many technologies that I will try to use, read, consume that content that rely on you using the language correctly. And like I said, good developers use languages correctly and make the most of the language that they're using. Now, much like the DOM tree is constructed off what we provide it, the DOM tree is also it also takes the DOM tree and it modifies it into something that's more useful for assistive technology. This is called the accessibility tree. And it uses the native semantics of HTML to create an interface for reading and navigating the page. So for example, a screen reader is able to interpret the accessibility tree as speech. Now, major browsers like Firefox and Chrome, they have what's called the accessibility inspector. This one is from Firefox. And like the DOM tree is made up of what we provide it, so is the accessibility tree. And as you can see in this example with all of my divs, it's kind of not very good. I don't know if you can see that very well, but it's all sections and there's a stray line just for a comma. It's much more complicated and unclear. In comparison to where we use HTML more correctly, where things are grouped, again, there's a structure, there's a hierarchy, there's a lot more information, and it's a lot more defined. And a really good way to demonstrate this is through the use of a screen reader. Now, I'm going to use Apple's VoiceOver. I hope that the audio works. Let's give it a go. Nah. It's not working.
Dogs are good. Web content.
Okay.
Home. Good dogs. Bad dog myths. Dogs. They are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. By Mandy Michael, August 3, Road 2018. Why are dogs good? Dogs are loyal, intelligent, devoted, and affectionate. They are known to improve our physical and mental health. Jello, also known as Jello. /screen %, 20, shot %, 2020.
Okay, I'm not going to make you listen to that. You might not have heard it at the beginning, but it read the links at the top out as text. And the reason it did this is because what makes them links is an on-click event, which the accessibility tree doesn't know about, so it just thinks that those links are text. It also read out that terrible image file name because I didn't add an alt attribute, and I didn't rename the file. It was a screenshot from Instagram. So it also read out the date wrong. It said road instead of third. So, it's not great, right? There's no context. It's okay, but this is a pretty simple page. Imagine how that would be if it was a lot more complicated. In comparison to this page,
you are currently on web content. Dogs are good. Web content. Navigation main navigation 1 item. List 3 items. Visited. Link. Home. Link. Good dogs. Link. Bad dog myths. Heading level 1. Dogs. They are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. Mandy Michael. August 3rd, 2018. Heading level 2. Why are dogs good? Dogs are loyal, intelligent, devoted, and affectionate. They are known to improve our physical and mental health. A dog named Jello, also known as Jello.
Okay, there might be a little bit of messaging to try and push that dogs are good. If you don't believe that, that's okay. Any animal is also great. But you can clearly see, right, this is a lot better. It said that there were links, how many there were, whether or not I'd visited them. It told us about lists, it told us what headings were, the image was better. It wasn't great, actually. I should have put a better descriptive alt attribute, but it was better. We're giving the browser and the accessibility tree the information it needs to present the content in a more meaningful and useful way. Much like we do UX for design, you can kind of think as HTML like UX for assistive tech and other technologies like Siri, reading apps, Google search, which rely on your HTML in order to glean that context from it. And if we don't provide that context to the user, they have to do more work, but so does the browser. If we present the DOM with a large amount of information, it means that the accessibility tree also needs to do more work to figure out what to do with it. And as you might imagine, like when you throw a bunch of information at the browser, it's going to slow it down. And that's further going to slow down the accessibility tree. Now, I saw this great talk by Eric Bailey. You can check out his talks on Noticed, /Eric W. Bailey. And he talked about this problem with the accessibility tree, and it was fascinating. He's an inclusive design advocate, and in his talk, he said that when the accessibility tree is slowed down by excessive code, it can create a lack of synchronization between the current state of the page and what the user is presented by the assistive tech. This results in a mismatch between the page and what the user is presented with. And as you can understand, I'm sure, that's very confusing. It's like having shitty dubbing or lag in a video game. Not a fun experience. Additionally, a large, complicated accessibility tree can crash the browser because the more information you put into it without any context, it's just going to dump it all in there like a big blob. You know, like when you save all of your files to the desktop, and then it just becomes like 1,000 files, and you just end up deleting them or putting in that like for later filing folder. It's too much, you can't deal with it, and neither can the accessibility tree. And this is why it's important that we consider what information we're sending to the browser. Now, I know, because you're all good developers, that you care about accessibility, but if you don't, or it's not top of your priority, I should say, I know what businesses are like, it's not just the accessibility that matters. Bad HTML can also impact your web page performance. Google's Lighthouse tool recommends a max depth of 32 nodes and no parent node with more than 60 child nodes. Now this seems like it's not very much, right? 32 nodes, 62 nodes. But when you're building at a component level and you're adding a div here and a div there and a wrapper over there and this thing here, it's kind of easy to forget that it's all got to go onto one page, right? So at the end of the day, it's all going to add up. And we don't ever want to hit that 32 nodes. That's like having a bomb that's going to detonate and then you leave it to the last second before you try and stop it. We want to be on the low end. But the good news is that there are a few things that you can do to make this really easy for yourself. And the first one is, like I mentioned earlier, don't just use divs. I'm not saying don't ever use them, like they do have a purpose, just don't only use them. I'm pretty confident everyone in this room could memorize these, or whatever your day-to-day HTML elements would be. So get to know the ones that are available to you and use the ones appropriate for your content. This is going to help you create something that can be more easily read by the accessibility tree and help you create more performant websites, all by using HTML the way it was intended. And you already have to write it, so why not make the most of it? And there are some simple things that you can follow. I'm going to talk about a few kind of beginner things here, mainly because it happens a lot, so I'm not sure it really is a beginner thing, and I thought it was important to touch on it. The first thing that I would suggest to people to write good HTML for performant websites and good accessibility, use the named element for what you're building. If you have a header, use a header. A button should be a button, a footer should be a footer, a label should be a label, a section, an article, an input, an input. A link is not a link, it's an anchor, but that's not a good example. For the most part, use the element that's named accordingly. HTML is intentionally simple, especially the newer elements that were added in more recent years. The elements are named to help you out. It's not a trap. You can embrace it and use the things that are named. They're not here to trick you, for the most part. And the same applies to headings. They're numbered for a reason. Use them in order. They have a meaning. They provide a structure and a hierarchy. And when you use them out of order, you mess with that hierarchy. And I know that developers don't love hierarchy. We like to rebel against it and have that nice flat structure in our organizations. But in the case of headings, I would say, please embrace them and use them in order. And this is particularly important for accessibility because assistive tech tends to use headings for navigational purposes. So people will often use the keyboard shortcut to jump between headings, or they'll use the rotor, which is this. Now, the rotor is a part of accessibility devices which kind of groups information, headings, landmarks, links, and it presents them in this format, kind of like a table of contents. And you can click through them to click on and jump to those sections. But I do also know that sometimes it's not as easy as it sounds. For example, if you take a design like this, very simple, where you've got a big heading and a little bit of text above it. That little bit of text is often referred to as a kicker or an eyebrow, which is weird. I'm not going to call it that because it makes me a bit uncomfortable, but if you're Googling it, apparently that is also a legitimate term. And normally, we would mark up this where the big text is a H1, and then we would do something else for that little text. But what do? Normally, you'll see stuff like this. H3, H1, div H1, span H1, paragraph H1, stuff like that. I personally would do this. I would say a H1 with a span inside, and then HTML and its benefits as the main text. And then I would use CSS to style the span to match that. And the screen reader would read this out as good developers, HTML and its benefits, which is great. But I think this largely depends on context, because good developers might actually be a better heading one than HTML and its benefits. So what I like to do is think about the content completely separately from design. If I was to write this in a Word document, how would I structure the headings? The design isn't really that important. We can use CSS in order to replicate that if we need to. potentially controversial take, and I say this with the deepest respect for designers, especially if there are any in the room. Just because it's in a design does not mean you have to do it. You don't have to. You can always say, is this necessary? Design and development are linked, and they should be worked on together, not in isolation. Never be afraid to discuss potential changes if it doesn't make sense once you get to the implementation phase. Because the context of this stuff does matter. And a really good example of this are date inputs for forms. Now, whether it's native or a JavaScript library, there are a lot of ways to represent dates. If you want to do it the native way, on an input you can use the type attribute with a value of date, and that'll give you, at least on the web, this little calendar-y doodad. But whether it's a native input like this or a JavaScript library, nearly every implementation of a date input is a pain in the butt for some group of users. And that's because they're difficult, not just for accessibility, but just in general. I don't know how old everyone in here is, but I'm getting on in tech years. And every time I have to put my date of birth into one of these stupid forms, I'm humbled by how far I have to scroll back to reach my year of birth. But what if I told you you didn't need to use type date for every single date input? Now, I know I literally just said this, and I'm going to say that is still good advice, but I also said that context matters. And maybe we don't always need a complex date picker like a calendar, because we ask for dates for all kinds of things. Birthdays, anniversaries, scheduling appointments. There are basically two kinds of dates: discoverable dates and known dates. Now, if you need to find unavailable dates, look for a date range, dates with a start and end matters, then we need them to be discoverable, right? And a complex UI like a calendar is very useful. But if it's a known date, like a birthday or a holiday like Christmas or Halloween that's coming up, anniversaries, we already know what they are. They're fixed dates. We don't need to search for them. So rather than interrupting the user flow by making them click through frickin' looking for their old birth date, you can just use a text input. Now, there are some things you can do to make that text input better. This is a great article called Maybe You Don't Need a Date Picker by Adrian Roselli, and I highly recommend you all check it out. It's very, very good read. But the point of this, because this is just an example, right? The point is, before you put code in as habit, consider, is it genuinely going to be helpful, or are you just doing things the way you usually do them? And this is a good lesson for basically anything that we build on the web. You don't have to just do things because it's in a design, and you don't have to just do things because that's how you always do it. Now, with that in mind, I do think we should absolutely be making the most of the built-in functionality that HTML provides. Now, it's not always going to be the right choice, like I've just mentioned, but more often than not, you should favour native functionality over creating your own. And part of the reason for this is users just get used to the native stuff rather than some custom thing that you built. And I get it. We like to build JavaScript libraries, but honestly, we don't need more. There's plenty of them. I do love JavaScript. I'm teasing it a bit, but it is great. A really common issue with this is links and buttons. Now, again, I know this is basic, but the amount of times I see people do this makes me think that maybe it's not. Maybe using a button is more complicated than I thought it was, and that's fine. To make this accessible and to replicate all of the functions that a button needs, you have to write at least this. At least. This isn't even everything that you need to do. I couldn't fit it all on the slide without making my text real tiny. So by the time you've written all this code and you unit tests for it and you've tested it and maybe you've done an integration test to make sure that the actual thing works, you're going to just use the button element and then just done the integration test or something. Now, I like comparison tables, so I've made one for you, and I wanted to make it really clear which one of these is bad for buttons. Buttons are clickable and tappable by default. We had to add on-click. A button is focusable. I had to add a tab index. A button can be clicked with the enter or space key, so there's keyboard interaction. I had to add the key down event listener. A button is going to announce that it's a button to assistive tech. I had to add a role. A button will submit and reset a form. It can be disabled with the disabled attribute. It's reported to the accessibility tree by default, and it has active hover focus and disabled states. Why? Why would you do the other way when you get all this for free? Now, I get it. Some people do it because they don't like CSS, and they don't like how the browser adds the styling. But I'm going to pause for a sec. You can just Google this, a button CSS reset by Andy Bell. Copy that into your page for your CSS, and then just use the button and sort it. This will make it back to nothing, and it'll be like it's a div visually for you, rather than doing this, which is a lot more than this. So please use a button. And similarly, if you need a link, use the anchor element. I wish this was named better, because that would really drive home my point, but sadly not. Links will navigate to a page or view. They'll change the URL, they cause the browser to read or refresh, they're focusable, they have keyboard interactions, they open tabs in new windows, they're reported to the accessibility tree, and they have all of those great CSS states. Make the most of it. Now, if you were paying attention, you might have noticed that there was some overlap between a link and a button. And sometimes these are used interchangeably, not just in design, but in development as well. But it's really important that you use them correctly because they do different things. So a good rule of thumb, from my way of thinking, is if it's got a href, you should use a link. If you disable default functionality with something like prevent default in JavaScript, then you probably wanted a button. So a link will navigate to a new URL or view, whereas a button will trigger something in the interface like a video player or a pop-up. And using these things with all that built-in functionality is just like using a pre-installed JavaScript library. You don't have to install another npm package with all of those hundreds of files that come along with it. You can just use HTML and get all that for free. Unless JavaScript is good, because that gives us smaller JavaScript bundle sizes. And we like them because it improves our performance. So make the most of the built-in functionality. And like HTML elements, attributes also come with a lot of built-in functionality. And that's what I want to talk about for the rest of the talk. ARIA attributes are a really good example of this. The main purpose of ARIA attributes is to fill the gaps in standard HTML so you can give more context to the accessibility tree than HTML would normally provide. And there is a lot to talk about with ARIA attributes. Things like ARIA pressed, selected, expanded, grabbed, do what you might think. They indicate that those actions have occurred on the element. ARIA live indicates that a section is going to be updated. ARIA hidden hides things. ARIA labeled by indicates that that element is labeled by. I always stuff up trying to remember how to explain this with all of the labels. It identifies an element that the label applies to. Really common in forms, like if you're doing error messaging, you can use that to say, oh, this is the error for this input. But to be honest, unfortunately, I would need a whole separate talk to go through everything with ARIA attributes. So instead, I'm going to give you some advice from Perth's local amazing accessibility expert, Julie Grundy, who is sitting at the back there, so hopefully you can clap for her later. She said, this is a great quote. If you're writing CSS and JavaScript that conveys information, ask yourself, is that information also in the accessibility tree? If not, a bit of ARIA might help. And that's a good way to think about it. And you can always inspect the accessibility tree, like I showed you before, to see what you might need or what's missing. But I would add to that where possible, you should use HTML attributes over replicating it with ARIA. And so really, you're just using it to fill gaps. So I'm sorry I'm not going to go through them in detail, but I do recommend you check it out because there's a lot of useful information that you can provide. So I'm going to give you a really quick run through of a few attributes that I think are really handy before we talk about performance. This one is called the accept attribute. And what it does is you can apply it to an input with a value that's a comma-separated list of file types, and it will only allow users to select those file types from the system. This is like built-in validation before they've even submitted, which is great. Same applies to the pattern attribute, which allows you to define a regex, which will assign a pattern that you want the input to match. Again, built-in validation. With this one, though, I would say it's very important to indicate what that pattern is near the input, because otherwise it's very confusing for people to know what they're supposed to match. It's just like guessing with passwords and stuff. Another one I love, I've used this before in presentations to make code editable, is content editable, which makes elements editable by the user. Might not seem very useful, but it is really great in like admin systems and stuff like that. It's also useful if you want to use the spell check attribute, which does as you would expect, allows editable regions to be checked for spelling errors, which again, this is kind of like helping people to put content and data in correctly before they've even submitted it, which I think is great because I don't know about you, but in the system that I work in, the data that we get is often very bad because the validation that people, we're relying on people to put it in right and they just never do. So these kinds of things you can make the most of by just adding an attribute. And the rel attribute, probably the most complicated, has all of these things. I'm not going to go through each of them. I will talk about a couple of them soon. But the rel attribute determines the relationship between a linked document and the current document. And it's worth checking out because as you can see, there's a lot of things that provide additional context, but also a lot of functionality as well. Now, there are a lot of great HTML attributes. They have good functionality that you can use. But the ones I wanted to focus on were ones that will help improve your loading and performance. And the first one is preloading of off-screen images, also known as lazy loading. Images typically take up the most bandwidth of any other resource, and they tend to be one of the biggest impacts to performance. This is an example from Google's lazy loading page, which I loved because of the cats, so I just stole it. And as you can see, as you scroll down, each of the image is loading in. So basically, lazy loading defers loading of an image until it reaches a particular distance from the viewport. So rather than loading all of the images at once and taking a long time and impacting your performance, you just load them when you need them. Previously, we would have handled this with something like the intersection observer or event handlers like scroll and resize, but we don't need to do that anymore because we have lazy loading native in HTML. And all you need to do to use it is add the loading attribute with a value of lazy. You can apply it to images, images inside the picture element. It also works on iframes, which is great, but not in Firefox, hopefully soon. Its default value is eager, but that is basically like not applying it at all. It's really only used if you want to override a JavaScript library that has it that you don't want. Importantly though, you should only lazy load images that are not in the viewport. An image in view when the page loads is considered part of the largest contentful paint, which is a performance metric that refers to the render time of the largest image or text box visible within the viewport when the page first starts loading. If you try to lazy load an image that's part of the largest contentful paint, it'll actually negatively impact your performance because it's not going to be loaded as quickly as you would have liked. So if an image is going to be in view when the page loads, you don't want to use lazy loading. As far as that distance value is concerned, it varies between browser. For Chrome, they use a combination of resource type versus connection type. The resource type makes sense. Larger file types are going to need longer to download than others. The same applies to connection type. Because on a slower connection, you're going to need more time to load that in than on a fast connection. Otherwise, you risk the item not being loaded in by the time that you need it. You can experiment with the impact of that by using the network tools in the code inspector, and you can throttle the connection and see the difference between the loading. You can also take this a step further by using the fetch priority attribute. And this is going to help optimize that loading. When the browser is passing a web page, much like I explained earlier, it begins to discover and download resources like images. It then assigns a priority to those in attempt to download them in an optimal order. Now, with fetch priority, you can specify a priority for things like CSS, fonts, scripts, and images. And it has 3 values. Assuming you're not trying to contradict base browser requirements, you can say that you want a high priority, so you want the browser to prioritize it. A low priority, you want the browser to deprioritize it. Or auto, which is the default, which is you do what you want, browser, you know what you're doing. But fetch priority really is only setting a relative priority. It's not going to help resource be discovered quicker. It's still going to make a decision on what the relative priority is, and it's just going to raise it by a higher or lower amount. A really good use case for this is image carousels, which I know, unfortunately, many of us still have to do. And you can assign a fetch priority to the main image, a fetch priority of high, and that will prioritize the main image over the remaining ones. And that's really going to help you with that largest contentful paint metric, as it's prioritizing the first image that you need. And you can combine that with lazy loading as well to improve your lazy loading experience. If you set lazy loading as well as fetch priority high, it'll still be delayed while it's off screen, but it will then be fetched with a higher priority when it's in the viewport. There are a few things you can do with it. Assign it to iframes, script, and link tags, and you can also use it in JavaScript to prioritize API calls. Now, while the browser takes a suggestion for fetch priority, it also does a lot of things to help improve page load performance by trying to guess what the user is going to do next. So, in addition to that, we can make use of resource hints to be more explicit about what we want. Resource hints allow us to tell the browser what is likely to happen next so that we can make better choices. And it's useful because requesting a resource from the server can take a very long time. So handling these ahead of time can make your applications feel a lot faster. We can accomplish this with the rel attribute. These are 2 of the values that rel accepts, preconnect and DNS prefetch. With preconnect, if you add it to a link, it will load the resource more quickly because the setup process has already been completed by the time that the browser requests it. Essentially, it informs the browser that you intend to establish a connection to another domain, and you'd like that to start as soon as possible. This can speed up load times by about 100 to 500 milliseconds by establishing early connections. And that might not seem like a lot, but it can make a big difference to the perceived performance, which is what people perceive how fast your page is. However, if you're making a lot of connections to third-party domains, pre-connecting all of them is counterproductive. It's not going to do what you want, so it's best to keep pre-connect for only the most critical of connections. And for everything else, you can use DNS prefetch, which is going to help you save time on the first step, which is the DNS lookup. And that usually takes about 20 to 120 milliseconds. Now again, I slide again. It might not seem like a lot, but everything adds up. So by using just a few HTML elements in your applications and web pages, you can get some really good performance enhancements before you've even started tracking performance. So if we can make the most of HTML elements and attributes, and we can improve our performance and our accessibility, and we can stick to some simple rules, we can make really big strides to making things more useful and more usable, not just for your performance and accessibility, but for our users and for different technologies as well. And all by using a technology we're already using. We're just using it better. What I'm kind of hoping is that the next time you're working on a component, a page, a product, you make the most out of what HTML provides, and you dedicate just a little bit of time to choosing the right element and attributes for the content. You pick the right type, because there's so much to be gained from using HTML properly and so little to lose. HTML is not just the foundation that we build our websites on. It's vital for making things accessible, usable, and performant. It's like a hack for making good websites and applications. And I don't know why you wouldn't want to make the most of that and save yourself a heap of time by utilizing all that functionality. And if you use it to its full potential from the beginning, you make things easier for yourself, for other developers, not just now, but in the future as well, because whenever the browsers improve those native features, you get those as well. So please be a good developer, make the most of HTML and all it has to offer. Thanks Burnt Toast Creative for their amazing illustrations that they let me use, and special thanks to Julie for her accessibility knowledge, and Eric. And here's all my resources. If you want them, you can come see me later. Thank you.